Good evening, everyone. I am going to record a different version of something that's already on my YouTube channel. I recorded a class on Sunday, but the audio was really bad. So I decided to record it again as a podcast. I changed some things up. Of course, there's no discussion questions, but on the other hand, I have a few graphs that I didn't think would fit into the class, but now they fit into this. So this is going to be an introduction to natural theology. Most people don't even know what that means, but I think it's one of the coolest things that we have. Although it has certain limits, it's a great place to start talking about how faith and science go together. And in fact, it goes along with a very famous statement, "By it I see everything else." This is a statement you might have seen quoted by C.S. Lewis before, and it's the one statement that is carved in stone on his memorial stone in Poets' Corner in Westminster Abbey. So if you go there, you see a bunch of other English poets, and you see C.S. Lewis up there with his stone saying, "I believe in Christianity as I believe that the sun has risen. Not only because I see it, but because by it I see everything else." And it's the idea that God is not only what we think about when we think about God, but gives us everything else. God is the whole foundation of being. So when we look at something, when we take it apart with science, actually that's part of the world that God made. Now there's very important caveats and nuances to everything that I'm saying here. But the whole point is it rests on this theology of creation, where God made this all through Jesus, through the Spirit, the triune God working together, and that Christian belief bears itself out in a way of faith that is not only compatible with science, but actually generates scientific thinking. It's done so historically, and I'm convinced to continue to do so today. This is a big statement, and I'm not going to be able to completely defend it in half an hour. But what I want to do is I want to show you how I guided the class through it on Sunday. We were in a chapel, and it had stained glass and big vaulted ceilings. And I said, notice how this room, this chapel, was built. Someone shows everything in the image that you see there, even down to the piano. When you look at the piano, you know that music was important to this, to fill the space. It was a lofty space, much taller than most things, to evoke heaven, even the dome of heaven, the image in Genesis 1. Which we use a different image to describe the reality that we see above us when we look out at heaven. And that image is better fitting with science. But at the same time, we can try to look at the dome of heaven with the eyes of the original writers of it. And we can get a lot of, we can think about what that would be like. The other thing that I notice in this, so you can tell a lot about God from looking around the chapel space. The architect of the space was trying to convey certain theological truths and the way they built it. But there's not that many words on it. There's a couple of words on the stained glass, but they're not the primary way that the meaning is conveyed. And so I want to ask that question about science. What is the light doing in this picture? And the fact is, if it's bending when it comes through the glass, it's refracting. Some of it is being absorbed and producing the colors that you see in the glass by the light that's being transmitted through the glass. And the light is reflecting off the piano. And you also have other things light can do, like light can diffract. And that's actually one of the properties of light that I've used in my own science. X-ray diffraction is a way of determining the structures of proteins. So I'm very keen on the idea that light can diffract. When you look down at what light is doing, you can ask what light is. And one of the interesting things about this very fundamental property, this very fundamental particle, is that it's not just a particle. It's also a wave. Light is a particle or a wave depending on the context. It's not like it's oscillating between the two. It is actually both at once before it is observed. And I think that this both-and situation is very interesting to think about as a Christian who has triune theology. The Trinity is sort of a 3 times both-and situation. Is God the Father, the Son, or the Spirit? Well, the answer is yes, both and, at the same time, simultaneous, distinct, but coexistent, co-eternal. So that's where you can get into some interesting resonances between scientific findings and theological findings. But we've got to always remember the rules of the game. Science is always done on things that in some way we can take them apart. In some way they are below us. Theology is always done on something that's above us. We can't dissect God. And so there are some things that theological questions are in theological language to answer it. Those are suitable for certain things, and they are not suitable for some things that we can look at with science. So it's a big deal, and there's a lot of nuances, and I love to think about it, and I can go down rabbit trails. But the main thing I can ask is you can ask, what is the light doing in that picture? And because Christians believe that God created light, there's something about the particle-wave duality that tells us about who God is. If we look at it right, and if we are aware that our interpretation can always be wrong. You can ask, what kind of creator would make a world like this? And it's a world in which we can make things ourselves. We can fail spectacularly at it sometimes, but we can try. You know, what kind of creator would make a world with wave particle duality for light, right? What kind of creator would make a world with quantum mechanics? What kind of creator would make a world with statistical mechanics? Or classical mechanics? You can ask a lot of these questions, and as a scientist, it's something with, you approach it with fear and trepidation, right? But you still approach it. And you still believe, if God made the world so that we can discover it, let's discover it. And let's put it together with God's revealed word that God reveals in ways that we can't discover, that we can learn in other ways. So, I'm a chemistry professor. And I ask these kind of questions. What kind of creator would make a world where chemicals cause life, where chemicals evolve and life evolves? What does that mean? And let me say right away that this is, I'm going to speak about evolution as part of natural theology. I'm going to speak of the immense age of the earth, the immense deep space of the universe. All of these things that science has discovered, I believe that they are not wrong in this, but instead we might be wrong in how we apply it to theology. So let's get both of those right, and then let's align them, juxtapose them the way we can. The basic answer, and the theological thing I want to focus on today, is that God's grace is superabundant. Not just abundant, not just there, right? But more abundant than we could ask or even think. Just like God's self is more bigger. You know, that even word is sort of weird, but it's bigger than we can ask or think. So we do have to be really careful. The same room that I gave this in is inside that building that you can see right there. And what happened is that a thunderbolt actually struck the church once. Now, if we were going to take natural theology too far, we'd say, what was God saying with the thunderbolt? And was God smiting the worship band that was practicing at that point? They've now patched it up, but you can see that the thunderbolt, we can say, well, it came down there because that's actually the highest point on that side of the hill, and that's where lightning likes to go. Okay, that's one way to answer why. But we really don't want to take it too far into why. It's obviously not true that the lightning was some kind of judgment from God on the people who were inside at the time. By the way, they're all okay. So natural events always have to go through a stage of interpretation. And guess what? The biblical text also has to go through a stage of interpretation. Nature only goes so far. And that's the important thing. Even the best done natural theology will only take you so far. An image of this is like how Dante talks about Virgil. Virgil, in a sense, is just natural theology and natural law and natural poetry is basically natural. Virgil is natural. And Virgil takes Dante through the Inferno and through Mount Purgatory. And then Virgil leaves when Dante enters the Garden of Eden at the top of Mount Purgatory before he is ready to go to paradise itself. Virgil can only take Dante so far. In the same way, we're starting with natural theology, but it can only take us so far. And there are heavenly things that we must speak of with other terms. God has revealed his fullness in Jesus for these heavenly things. And the good news is we can see Jesus. We can look at him. We can understand the words that he said. And so we can go along with Jesus and those who follow him to proceed through the last volume of the Divine Comedy. But I do want to point out that this is only an introduction to an introduction. If it's an introduction to natural theology, that is only an introduction to theology. So in the previous week, my colleague and friend Rod Stiling had described how Emperor Constantine set the date of Easter in the early 300s. And one of the things that Constantine did, he established the church as the official state church of the Roman Empire. And then he had to solve certain problems, like, when do we celebrate Easter? We are all the same church and we have the backing of the empire now. So the empire decides these things. And he made his decision in a very honestly flawed way. He said basically we shouldn't celebrate Easter associated with Passover, even though the first Easter was very associated with the first Easter's Passover, right? But he decided to say that because the Jews had killed Jesus, therefore we shouldn't celebrate Easter close to Passover anymore, which doesn't even really make sense if you think it through. It's not a good argument, and it's based on an incredibly flawed premise. And it ignores the fact that Jesus was Jewish, right? There's all sorts of things wrong with it. But they were stuck with it, and the Roman Church went with it because, the emperor's saying it, so it's what we're going to do. Now, at the same time, if you know your history, the Roman Empire soon fell. The Roman Church continued, but there was sort of a dark age where the empire had crumbled, and it wasn't very easy for knowledge to get around, and people just didn't have the bandwidth to be able to dig into these things and preserve these things. In fact, there's a book that argues that civilization was preserved not by the Roman Church, but by the fact that a Roman named St. Patrick brought the church to Ireland. And Ireland was so far separated from all the rest of the stuff going on, Ireland produced a strong culture of preserving the information, and they even had a separate church that had basically lost contact or communion with the Roman Church. They did things their own way. And so St. Patrick preserved the knowledge, and then they brought that knowledge back to the Roman Church. When the Celtic Church, starting from Ireland, actually sent out missionaries to go across. And I just got to say, I named my own son after one of these missionaries. This shows the missions, and you see the arrows pointing out from Ireland, and they're going out to England. So Ireland sent missionaries to England. The Roman Church was also down there in the south, and they were sort of hanging out, and they were doing something down there, and soon the two churches met. And so in the mid-600s, they had the same debate all over again, because the Celtic Church celebrated Easter on March 25 of every year. It's kind of complicated, and actually my explanation in class had a slight misstatement. For example, I said March 25th was not exactly the equinox, but actually it was. It was the day they celebrated the equinox, and that's one reason why they might have celebrated Easter on that day. Also, it might have been the date of the Annunciation, because it is exactly 9 months before December 25. Okay, so whatever that thing was, the date itself was very important to them, but the Celtic Church celebrated Easter on that date, and they did not have the ability to celebrate Easter on Sunday every year. Every 7 years you'd have Easter on Sunday. So the Roman Christians did have a point, kind of Easter took place on a Sunday. It's the whole reason why we have church on Sunday. Maybe we should make it be Sunday every year. So they had to figure out how to do this, especially when the churches came together. And it was in the mid-600s, and the dispute was done basically right where the two churches met. It was done outside of York at Whitby Abbey on that part of England. Now, this dispute was resolved very differently than the Constantine dispute. You didn't have the Constantine figure. You did have a king who was pushing for the Roman Church's way of having a moving Easter date. And actually, the king, spoiler alert, the king got his way. And that's one of the reasons why we celebrate Easter on a moving Sunday every year. But it was not done with the same kind of bad arguments. It was actually done with good arguments. And it was done because of somebody who was later sainted, but sainted for a very interesting reason. This was St. Hilda, and she was an abbess. And really, she was part hotel manager. Because part of her job, and this is a very important job, but you don't want to say that it's what her management of the situation. Her hospitality is what made space for people to be able to come together and reconcile in peace. since 664 AD, where they had the Council of Whitby, I think it was called. And basically all these people came together, they adopted the Roman method, and Hilda made space for them. And in fact, it's not just at this point that Hilda made space. She made space for a community of scholars of all different sorts, of normal people of all different sorts, including a sheep herder, who eventually became a poet who wrote the first song in the English language, named Caedmon. So she supported artists, she supported scholars, of course she hosted the king when the king was there participating in the council, and she made this kind of space that was her gift. Now she's always shown now, and then she was sainted, and now we have her, with her abbots or abbesses staff. And but if you look at the symbolism, this is actually Caedmon's cross right next to Whitby Abbey. And if you look at the bottom, it looks like Hilda's standing on some swirling waters. But if you look at them real closely, they have heads. They're coiling snake-like creatures, but they aren't. They actually are spiral shells. Only some of them have heads. Whenever you see St. Hilda, this is her crest, and it has 3 spiral shells on it. Those are actually fossils called ammonites that are found on the Whitby beaches. Literally, Whitby Abbey is built on a cliff that contains these ammonites. So she was literally standing on fossils when she was doing all these things. And so they became associated with her. It's a real nice way to say what this place was. Okay. This is a view from the west looking east at Whitby Abbey. You can see it there. And you can see the cliff that it's on top with the beach underneath it. It's actually a pretty deep cliff and a pretty big beach. There's been a lot of erosion going on, and that's one of the reasons why the fossils are revealed so well at that location. And if you look at this, actually if you look at where the river is, the reason why there's a cliff there is because there is a fault there, a geological fault, a break in the earth underneath the surface. The break goes north-south, and in fact you can even see it if you look at the river that goes there. It's called the River Esk, and if we zoom in here, you can see that the River Esk sort of meanders northeast until all of a sudden it starts to go straight north, right about where Whitby Abbey is. That is where it meets the fault, and so it carves this deep valley through this already faulted ground, and it turns because it's basically running into the cliff, and then it turns north to go up to the North Sea. And so that action actually exposed all the rock underneath, and it dug down so deep that there's a lot of ammonite fossils. Here's an example of some of the ammonites. Some of them have actually become opalescent because they've been turned into opals by the action of geology over time. Those atoms that were once alive have been replaced by rock atoms in the exact same pattern of life. And ammonites can come in all sorts of shapes and sizes. Here is a medium-sized one, which is big enough to be something you can sit on. This is at the Redpath Museum outside McGill University in Montreal. And the other thing is, of course, people would pick those up and they'd associate them with Hilda, because she must have picked one up at least once or twice during her life. People had the question, how did they get there? And so people, of course, associated with Hilda, and they said, okay, Hilda was such a saint, she actually turned snakes into stones, sort of an echo of St. Patrick's story. But if you look at, and they even took some ammonites and some fossils, and they carved little heads onto them, looking like this. But this is a lie. This didn't actually happen. They were just doing this to sell something. Okay? So the thing is, they tried to make a story that fit it. But we now know that story doesn't work. In fact, the story of how they got there involves chemistry, because you had them being buried, and you had them being buried long enough that the biological atoms were replaced with geological atoms, with silica and calcium and things like that. And yet the shape was retained. So the reason why we know this is because we have science now, people who have looked at fossils very closely and have figured out the mechanisms by which things have consistently operated over time to produce them. And the reason why we have fossil hunters that did that scientifically, the reason why we have scientists, is actually in part due to the church. Now, it's very true that Galileo and many early scientists had a lot of conflicts with the church. Although if you look at all those, there's always a little bit more to the story than what the polemicists will tell you. But even taking those and saying we can talk about those another time, there's a positive contribution that the church made when it set up, when basically because of colonialism, because of the evils of colonialism, the church had a lot of money, had a lot of political power, and it wasn't very good at being a church necessarily, but it created a lot of space. And out of that space came some surprising findings. Basically, the church had so many priests and rectors, and they had a job that was like Sundays only, and so they had time for exploration. And out of that came many of the first scientists. For example, the first paleontologist, Reverend William Buckland, at least the one who first wrote the first full scientific account of a dinosaur, Megalosaurus, he was a fossil hunter who was a reverend. And so his fossil hunting was a side job, but now it's what he's known for today. And by the way, some of these were very, they had small congregations because they weren't very good at being priests or rectors. They weren't very good at being pastors. But out of the space of their lives, something good still came about. So there's one of the first inventors, the vicar, Edmund Cartwright. He invented the power loom, and that was used by the thousands and tens of thousands in the Industrial Revolution. There's a biologist, the Reverend Jack Russell. You might recognize that name. He bred the Jack Russell Terrier. And so you have all these different scientists, and that was a culture of experimentation. It was sort of the gentlemanly thing to do. And there was actually both sexes got involved, but of course it was mostly men because they were the ones who were the sort of failed pastors with too much time on their hands. But it did result in the culture of science. And that, inspired the first geologist, who was not a reverend, but he was an MD and a farmer. And from his farming, he started being interested in rocks. And he searched out and found unusual rock foundations and theorized about how they could be made. In fact, one of the most famous ones he found, James Hutton found Hutton's Unconformity. And I have a picture of that on the next slide. This is one of the extra scenes, and I just want to say this is all from Bill Bryson's book, At Home. And there's, for example, if you know the Malthusian economics, which inspired Darwin, well, Malthus was a reverend. Darwin was thinking about being a reverend. It was the thing to do. But they had a high view of the natural world. They believed God created it, and therefore they believed that we should chase it down. And that built science today. The inventor of the submarine, the inspiration for the flowering buddleia, there's all sorts of things. And then the Bayes of the Bayesian distribution, he was a preacher. He was very bad at preaching, but he was good at math. And he made Bayes' theorem. And so you have a lot of these things going on. So, and then there's the next generation. I think this is fascinating. A lot of the children of these reverends went on to do great things. Christopher Wren, John Dryden, Samuel Taylor Coleridge, one of my favorites, Lewis Carroll. They were all, and the Bronte sisters, Horatio Nelson, they were all sons and daughters of reverends and vicars of the Church of England. So to get back to what Hutton found, he found his unconformity, where he found the rocks very clearly are tilted together at this point on the coast. And they're like books on a shelf. And geologists later found the way to explain why these two very different types and ages of rocks could be slapped together. And it's a really excellent explanation for how this could come about. And the explanation was brought about by the curiosity which was engendered by the church making space. What's interesting about Hutton's unconformity is it was only the beginning. As scientists, they found other unconformities, and of course they wanted to explain them, right? Well, there's one unconformity that we keep finding all across the world. It's in the Grand Canyon, that's shown on the left. It's in Colorado, that's shown on the right, and it's in many other places as well. I know it's up in Canada. I'm not sure where it is outside of North America, but I've seen some hints that it was truly worldwide. And in fact, you can date the rocks now, and you can find out that the rocks underneath are always the same age. It looks like the rocks above it are always Cambrian age. They come from the Cambrian era. And the really interesting thing about that, so if you look at this picture on the right, this is an example of Cambrian sandstone, and that's a sandstone that is first full of weird fossils. Older than that, you have things, and now we can find life older than that, but the big fossils that you can see with your eye, those start popping into existence in Cambrian stone, and they have all these shapes that are very clearly different than what we have today. They're very clearly extinct species, and there's this profusion of life. So it's amazing. It's called the Cambrian explosion, where you had an explosion of life. So what can we put these two things together? We have the Cambrian explosion right after the Great Unconformity. And there's a lot of back and forth, but it really is becoming even more clear now than it was when I wrote my book, that the Great Unconformity was made by glaciers. And it was made across the world because there were glaciers across the world. They call it Snowball Earth, where almost the whole Earth was covered with glaciers. And it scraped down the mountains. And when you scrape down the mountains, you dissolve the rocks in the ocean. Life lives in the ocean. It needs water, right? And so if life lives in the ocean, all of a sudden it's getting a whole bunch of new chemicals. And so the Great Unconformity is a geological event that leads to new chemistry. Right after the Great Unconformity and the new chemistry, you see new life. And this is very suggestive to me. So I'm going to tell you a little story about how this inspired me. This is where I found out how we could go see Cambrian fossils. There's a lot of different places you can go to see the Burgess Shale, which is up on the line between two provinces in Canada. And it's a great deposit of the most diverse and easy to find creatures like this. Most of them you have to go with a group, but there's one that is located at this hike, which you can go to find, which you can just go up and hike up there. Probably because it was found after the trail was already established on public land. So I took my family there. There's my kids and my wife hiking up after me. You have to hike up, of course, because you're hiking up into the mountains. Our parking spot is sort of down by the road there, if you look all the way on the right side of the picture. And as you go up there, you see a clear vision of what glacial erosion looks like. A U-shaped valley, and yet this is very high up. This is carved by a glacier long ago, but it was carved in the mountains. It might have been uplifted some as well, later after that. But the hanging valley is what you see my kids sort of walking toward right here. And that's when you know you're getting close. The best part about this, when we reached this point, all of a sudden it felt like it was air conditioned. Because there's still a glacier up there, and the air is coming out of the hanging valley, and it's literally refrigerated. It's a very pleasant hike once you get up there. So what you do is you don't go all the way to the glacier. You can see the glacier sort of peeking out behind the cliff on the left side here. But you actually turn right and you scramble over to the waterfall. It sounds like some kind of quest that you have to do, and this really is kind of like a quest. You scramble to the waterfall and you find this rock field. And that's where the fun begins, because you start lifting up the rocks and turning them over. And actually, they even shatter apart easily, like you can even take them apart. They have a little box there for you to leave them there. So the one thing is, they're okay with you looking around. They just want you to leave what you found in the box that they have. And so that's what we did. Here's one rock that we found, and I think that this one looks like a weird Cambrian creature called Wiwaxia. And this, by the way, is an image by my artist friend Gayla Bent, who did about half the images for my book. So, yeah, whatever that is, whether that's Wiwaxia or not, it's definitely weird. And it's cool that you can just find them so easily. Here's another one. This might be Aishia. And this is the idea, is that you find all these rocks, all in the Cambrian era stone, which comes right after the Unconformity. So my question is, why did we do this? You know, we didn't do it to get fossils. We had to return the fossils, right? We did help them find a few new fossils, but I doubt that we found something that was truly earth-shaking. No, we took that trip because I wanted to make space for the kids. That's why you take any vacation. But we also wanted to shape our imaginations. And the cool thing is, I believe because the natural world was created, was spoken into being by God, It would shape our imaginations, and especially my children. They'd always know that the world is the kind of place where if you go to the right place, you can flip over a rock and find a weird little creature in the stone. So an imagination formed by this, formed by natural things like seeds sown and growing into plants and lilies and sparrows flying or falling, that's a bridge to the whole universe. This natural world provides the sacraments, and of course, what do the sacraments point to? They point to Jesus, and they were given by Jesus. And so we have this whole thing of there's all this going on, and I want you to look at that quote if you know the sayings of Jesus, and you'll see that many of the sayings of Jesus are echoed in that. Jesus loved to use natural metaphors. And amazingly, those are the metaphors that continue to resonate with people, actually until the modern age, when we don't get out into nature enough to be able to understand what Jesus was saying. So, if you want to learn what Jesus was saying, of course, learn his words. Start there. But also get out into nature so that you can grow some things in the garden. And you'll understand what Jesus was saying about seeds and growing and mustard seeds and things like that more. So, and the thing is, when you look at these, a lot of times Jesus is talking about abundance. The lilies of the field, even Solomon was not arrayed such as these. The lilies of the field are much more beautiful than Solomon. Jesus is talking about how the rain falls on the just and the unjust. That is much more, although it's not really moral, right? It is much more than moral. God gave us much more than we expected, and we found much more than we expected when we went on that hike. Paul, of course, picks up on this too. If you think about Romans 5, much more is woven throughout that letter. In fact, in Romans 5 alone, there are 5 much more statements, including where sin was abundant, grace was superabundant. And so I want to say, if this is the case, how is God much more? And by the way, much more can be a terrifying thing. It can be an invasive thing. It can be a natural evil type thing. How do we hold that together? But that's another lecture for another day. Or it's not a lecture at all. It's lived experience and walking with Jesus. But I won't talk about that now. So let's talk about the superabundant things like the fossils that we found, and the science that we built from finding fossils like that. This is where I have my 2 discussion questions that I ask people to find something surprising and superabundant in nature. And I ask, when does Jesus use natural metaphors? How are these much more than expected? Basically, the idea is that what God has put together, God made the world as one, God is one, and then the world sort of divided and diversified. And so God made the world as one thing, and when we move around, we can specialize in one area or another, but we should never forget that the walls that we put up between areas are not necessarily the walls that God put up between areas. For example, fossils showed that biology could turn into geology. And so from that you can start thinking, could a geological thing turn into a biological thing? Could a chemical thing turn into a biological thing? And I think it could. And I even have a whole chapter in my book that's about the origin of life. Some ideas, I don't say it happened for certain, but I say it could have happened based on these experiments that we can do in the lab right now. So the whole thing is that biology, geology, chemistry, they're actually fields in a world that the fields fit our human conception, but God made them. This also argues against gaps in knowledge, that God somehow made a world with gaps in it. Rather, it argues that the world has integrity, as God himself has integrity. Science and faith, they are separate activities and they have separate connotations sometimes, but they were both describe human activities that can take place at the same time. There are ways in which they can coexist and even benefit each other. The one thing I want to say theologically is the way that we work in this world is that we humbly make space for God to speak. We make space for the world to speak to us and God's word to come to us through the world, as flawed as that may be. And we definitely make space for the words of Jesus and for those to be really imprint themselves on our soul. If this is a gift from God, we're going to take it seriously. We want to look at it carefully, and we want to be humble about even our interpretation of it. We want to receive. We want to make space, like Hilda made space. So I think of the ancient prayer of St. Patrick with new words. Christ above me is astronomy. Christ beneath me is geology. Christ beside me is biology, the connection that we have with animals and plants. And by the way, that connection is very often mediated by chemistry. All of these follow rules with consistency and faithfulness from age to age, and that is where I start my natural theology from. So when I look at the Cambrian explosion, I try to think about how can I prove that this couldn't have happened in any natural way? But rather I say, what if there is a natural way? What if the big geological event led to the big biological event? And if so, that's a puzzle we can figure out. And so I talk about what the chemical cause of the Cambrian explosion might be in my book, Images by Gala Bent. And this comes from a theology that my mind has been created by God, as God created the life that was preserved in these fossils. So when I look at the fossils, the creativity, the shapes that they have, more than I expected. The age of it is also more than I expected. 600 million years ago. That's a long time ago. That's more than I can even fathom. But God could have made that because God himself is more than I can fathom, right? So my proposal is that the Cambrian explosion happened at that time for a chemical reason. And therefore it's predictable on other planets that might have happened. This is the kind of cool thing. But if you think about it, chemistry is universal. So if you have the same solvent, water, and you have the same building materials, amino acids, you might have the same general events with a lot of differences in between them. But you might have the same chemical sequence is what I'm saying. The world is intelligible, contains a deep structure, and that structure has chemistry. Now, I don't want to discount the deep freedom as well. Lots of contingent things can happen, lots of random things can happen. Randomness is real, and it's involved in the world. But it is also constrained by certain things like the periodic table. So my metaphor thinks of the elements as seeds of reason that were planted at the beginning of time, and only certain elements had certain jobs. Actually, if you read my book, in chapter 3, I talk about the different colors on this, or the different shadings on this, that refer to the 3 different jobs that elements can have. And the metaphor is that these were seeds that were planted in the universe, and they sprouted and gave birth to life. This metaphor is actually very old. It was first a Stoic metaphor, and St. Augustine used it a lot. And it actually was used alongside the laws of nature metaphor. So I like both metaphors, but I think that we should recover the seeds of reason metaphor from when people were talking about it in the late medieval, early modern period. The particular seed I want to talk about is oxygen, a seed that grew and developed and even could have caused the Cambrian explosion. And the one main thing, there's only so many elements. There's only 118 here, and only 90 of them, fewer than 90 of them, are naturally occurring, and fewer than that are abundant enough to be available for life. So there's a lot of things in which the periodic table is restricted. Yeah, we have more than 4 elements now, but we don't have that much more than 4 elements, and the story they tell would be a story that could happen wherever there's water. And so this is where I have my mini museum, and this is where I bring it out. Now, I'm going to have to cut this short because I'm going on a little while longer than I expected. So I'm going to go through this kind of fast. But the idea is that life reorganized things. I have little zoomed bits of my mini museum, but you can't see it anyway. So I'm just going to show you the zoomed bits, and those tell a story. Life was 3 billion years ago, but the life consistently needs to keep certain chemicals and reject certain chemicals. If you look on this, oxygen is one of the chemicals that is ejected by life. The very earliest form of life, and the photosynthetic life, actually produces oxygen. And at first you don't have oxygen, but then life makes oxygen and terraforms the planet. Oxygen is so important because it can do 3 different things. It has a very particular chemistry, forming 2 tight bonds. And most important, it makes fire hot. Fire always burns, and when you combine oxygen with any of the other common elements, you end up with something hot, something that releases energy. If you think about this, this is really a kind of weird thing. And if you think about, there's even journal articles about this. The other thing oxygen does is it actually will transform the world by literally oxidizing it and changing the balance of electrons that are in the entire place. Oxygen wasn't available at first because actually it was so reactive, it reacted with all the rocks, it got locked up inside the earth, there's nothing left for the atmosphere. So the atmosphere was without oxygen, which is fine for little bacteria, but it doesn't give you enough energy to run an animal on. We need oxygen, and it's very special chemically. You can argue that you can't make a complex life system, at least with these chemical pieces on the game board, without oxygen. So about 3 billion years ago, we start to see orange and black bands of rock, and this is where we can tell oxygen started to be made, because it put out into the atmosphere and then it got collapsed down into rusty rock. And then they put out more. And so you had oxygen sort of rising over time, and I literally have a piece of that in my mini museum. That happened about 3 to 2.5 billion years ago. And then the oxygen went up. This is a little bit of the detail, but I have to go pick up my kids, so I'm going to have to go pretty fast about this. It also allowed to make new structures. For example, oxygen allowed a chain of carbons to be turned into cholesterol. And in fact, there's a whole class of sterols and steroids that are built off this backbone. You can argue that that backbone gave the structure that allowed membranes to grow bigger, that allowed animals to grow bigger. So after it jumped up 2.5 billion years ago, then actually it stayed the same for a while, oxygen levels did. And about 0.6 billion years ago, all of a sudden you see the Cambrian fossils. The cool thing is that the Great Unconformity, that's 0.7 to 0.8 billion years ago. So you can see in geological terms, that is right before. And if you have glaciers that are scraping away all these mountains, you are ending up with the mountains dissolved. The oxygen is, basically oxygen is released, but it's released because other elements are being scraped into the water. Calcium and phosphorus are the prime examples of things that went up at the time, and all of a sudden we saw these calcium shells in the fossil record. The idea is that these are all linked together, and this allowed Snowball Earth and the Great Unconformity to release the chemicals that allowed life to become more complex. So the most extreme ice ages in history preceded the Cambrian era, and this is where it shows the Rodinia, the glaciations happened before 600 before present, and right about 600 before present, oxygen jumps up, and then at the same time, a little bit after, so close it's actually hard to tell in some cases, but I believe the evidence points to oxygen first, and then life right after that. And you even have extinctions where oxygen dropped and life dropped, and then it climbed back up again. So this is the way in which oxygen was a seed. It allowed for, even caused a world in which creatures could relate to their creator. And the whole idea is that oxygen is the seed that bore fruit, and the ultimate fruit is a community of thinking humans. We can understand God's words and God's creation, revelation and natural theology. The basic thing is mind matches world because God made them both. And think about one of the lesser-known parables that Jesus said in Mark 4 about the kingdom of God is like a man scattering seed on the ground, who sleeps, it takes time, but it grows and the harvest has come. My point is that this gives us purpose to creation, that God is infinitely patient. 1,000 years are as a day, 1 billion years are as a day to God. And the creation depends on God, but God also makes space for us and creates a world in which we can participate and communicate. So we can make space. So God calls us to make space for Him, to make space for Jesus in our lives, as God made space for us to exist in the first place, living in His light. And now I've got to go pick up my kids. But if you have questions, I'll be watching the comments. Thanks for listening.